Okay, today we are going to continue talking about one-step equations, but this time we're going to discuss two different inverse operations, okay? Raise your hand if you can tell me what operations we're going to talk about right here. Jaden. Okay, multiplication and division. That is our other set of inverse operations, okay? If we have something multiplied to our variable, then we can undo it using division. If we have something being divided to our variable, we can undo it with multiplication, okay? So today's examples that we're going to do in class, today's homework, we are only going to focus on multiplying and dividing, okay? Then we can kind of work tomorrow on maybe all four operations. Which one do we need to do, okay? Before I forget, since they're right here, T-shirt money and order forms are due Friday, okay? I don't have very many order forms, so if you are going to order it, please make sure that you get it done this week. I want you to have a T-shirt if you want one. Okay. All right, so let's come down here to example number 7. All right, I am going to circle our variable, or I'm going to put a box around it because I like boxes better. Okay. A is what we are solving for. Okay. Now, if I draw my line, Miss Newton likes to call it the fence, okay? If we draw the fence, what number is with our variable? 4, okay? Trent, how is 4 tied to A? What operation is in between 4 and A? Multiplication, okay? And here's something that's good to talk about. If there is nothing in between a number and a variable, we assume that it's multiplication, okay? So 4 is tied to A by multiplication. We're gonna have to undo our multiplication, and to undo our multiplication, we are going to have to divide by that number on both sides. Okay, so notice how 4 divided by 4, technically that's going to cancel out so that we're left with 1A equals, careful, what kind of 6? Negative 6. Don't forget that that 24 is negative, okay? Now, I didn't see this really happening in your homework. I do want you to check your answer to make sure that you got it correct, okay? Our equation was 4A equals negative 24. Well, we solved for A, and A was a negative 6. So if I come over here and plug negative 6 in for A, is 4 times negative 6 equal to negative 24. Excuse me. Okay, so we are good. Your nose gonna be okay? Okay. Back to normal. Okay. I'm sorry that you got the elbow to the face. All right, let's go over to number 5. And by number 5, I mean number 8, but there's a 5 right there. I don't know what my brain just did, but number 8. What don't you?
There's a problem ahead.
Okay, we'll get there. Just be patient, okay? All right, so where is our variable? P? Okay, so I am going to put a box around P. Okay, and I'm gonna go ahead and draw our fence. Okay. Now, it looks like negative 7 is on the same side of the fence with P, but I don't want negative 7 to be there. Bennett, how is negative 7 attached to P? What operation? Multiplication. So we need to undo this multiplication, right? And Braylea, what do we need to do with that -7 to undo it? We need to divide. So we're going to divide both sides by -7. All right. So the -7 divided by -7 cancels out to be 1. I'm not going to write 1p. If you write 1p, that's fine. But if p is there, we assume that its coefficient is 1. Okay. So p equals, okay. Our reason, what is -56 divided by -7? Oh, that is so nice of Trent to help you there. Thanks, Trent. 8. It's okay to say the wrong answer though. Don't be afraid. Okay. Nobody's gonna judge you. All right, so let's check our answer. Our original problem was -56 equals -7p. Well, we got 8 for p. So when we plug it in, is -56 equal to -7 times 8? Awesome, we got it. Okay, cool. Let's go ahead and shift our eyes to the next page. We're gonna look at number 9. Yeah. Yeah. I'm just gonna put this way over here. Just do your best. You got it. Okay, so here's our fence. It's not straight, that's gonna bother me. Okay, and I'm gonna go ahead and I'm going to put a box around my variable. Okay, n, we need to solve for n. All right, on the same side of the fence with n is that 5. Okay, Cordell, how is 5 being attached to n? What operation? Division. So we need to undo the division. Well, if 5 is being divided to n, then to undo it, we need to use the inverse operation. So we're going to multiply both sides by 5. Okay. When we multiply by 5, okay, those 5s are going to cancel out and we're left with 1n equals 45. Okay. Are you okay with why 5 times n over 5 is going to cancel out to just be n? Let's talk about that. When we're multiplying this right here, I'm going to zoom in. When we're multiplying, remember that 5 is the same thing as like 5 over 1. So when we multiply, we're getting like 5n over 5, which can then reduce down to just n. Okay, those are going to cancel out. All right, so let's check our answer. We have n over 5 equals 9. That was our original equation. And we solved for n to be 45. Is 45 divided by 5 equal to 9? Yes? Okay, good. So then let's look at number 10. Okay. I'm going to draw my fence. And there's our variable r. Okay. What I want you to do is I want you to take just like 5 seconds and turn to your elbow partner and decide what operation we need to do to undo the 8. Corin, what do we need to do? Okay, this -8 is being divided to r. So we need to undo our division. And to do that, Corin says that we need to multiply by -8 to both sides. Okay, so on the left side, we get -16. We have our equal sign. Remember, this is like multiplying by -8 over 1. So those 8s are going to cancel. Okay, and so we're just going to be left with r. -16 equals r. Okay, let's check. is 2 equal to negative 16 divided by negative 8? Yes, yes it is. All right, I'm gonna give you about a minute or so for you and your elbow partner to work on number 11 and 12. Number 11 and 12. What number is in front of K in number 11? It's like negative 1 times K. That's like negative 1 times K. Does that help you? Okay, take this time and consult with your across the table buddies and make sure all 4 of you have the same answer. Are you good with your across the table partner? Are you sure, Ryan? Okay. Okay, so we decided that basically this means there is a negative 1 K equals 7. Okay, so Quinlan, what did you and Trent do? What? Okay, so negative 1 is tied to K with what operation? Okay, so we need to undo the multiplication by dividing by that negative 1. And you said we're going to get K equals negative 7. Okay, how do you feel like Trent and Quinlan did? Good. Does your work look like that? If you only have K equals negative 7, I don't want that. I want you to show your work, okay? I know that some of you are like, oh my gosh, that's so ridiculous. I can do it in my head. But when we get to 2-step equations, we're really going to need to show our work, okay? Number 12. Number 12, okay? Olivia, what did you and Cordell do in number 12? What did you do to both sides? What operation is that? Okay, so Olivia is saying that she multiplied both sides by negative 6. Is that what you did? Yeah. Okay, so here is X. We need to undo the division right here. So we're going to multiply both sides negative 6. Okay, so this is like multiplying negative 6 over 1. So the 6's cancel, boom, boom, and we're left with X equals, oh my goodness, negative 12 times negative 6. 72. Okay. Okay, so guess what? Your homework is page 7. And we have 10 minutes left in class to do 10 problems. I bet you can get them done.
Once in a while.